PhD in mathematics. And my PhD in mathematics is in mathematical logic. I'm a full professor and I'm mathematics department chair. And my topic is common sense and word problems.
Mouse. And then hover in the corner.
Yeah. Okay, great. Okay, so that's my topic, and just introduction. My research on math anxiety led me to historical roots of teaching mathematics also. I researched the teaching methodology of Ananya Shiragatsi, a famous Armenian mathematician of the 7th century. Ananya Shiragatsi's book is one of the oldest math, I would say, arithmetic textbooks that is survived fully. And in that book, Ananya Shiragatsi talks about methodology of teaching arithmetic to children. And that methodology was used in Armenia for centuries, and it proved to be very successful because students learned math for good, not to memorize and then forget very quickly, after getting grades, right? Which we have seen many times, and it can be used even now in the 21st century. Okay, so why common sense? Because we have common sense, we can make simple conclusions from couple of information having, right? That's common sense, and every person has common sense. Unfortunately, many students don't use it. There are some research done in using common sense in learning, teaching, and learning mathematics. In some cases, I have noticed that they are not really understanding common sense wrongly, intuition, which is kind of it's a good skill, but it is not common sense for sure. So also another thing that I noticed in research is that in schools, mathematics teaching has tended to promote skill in handling routine numerical, algebraic, and geometric operations. They just know what steps they have to do. They just go through steps. They succeed. What are the steps? They have no clue sometimes. Even I would say very often. Consequently, students get bored handling routine operations they do not understand. Also, teachers convert classrooms into test prep centers. I can't blame teachers because they want their students to be successful to pass the test, right? But making tests the purpose of the class is, I don't think it's the right thing to do. This teaching methodology results in learning mathematics by rote, not by understanding, which cannot develop common sense. Okay. The more people are trained to think one way, and many people are comfortable, right, thinking this the same way, by our workplace, family, culture, etc., the greater the chance that sometimes we allow sloppy or autopilot thinking to replace common sense. The effect is that some adults stop using their common sense, and I have seen that a lot. I've seen it at the university among my students. I have seen it in the streets. just like people talking, and I, as a logician, I immediately kind of, my approach is logic. Is there logic what they're saying? No, there is no logic. So, students stop using their naturally existing common sense in learning mathematics. Common sense is a way of thinking that needs constant nurturing and application. So, what are my findings in all this? Teaching mathematics using common sense cannot be effective in teaching mathematics to adults who are accustomed to not using their common sense. Our university is for adults, and that's why my interest is also in how to teach mathematics to adults. And as I said, I have noticed that many adults don't use their common sense. However, the same methodology can be effective for pre-K, K, and elementary school children who are not yet accustomed not to using their common sense. This methodology will teach children to use common sense and develop their analytical thinking. A logical definition explanation will help students understand, eliminating memorization. Therefore, it will not require students to spend hours on rote learning and memorization. Solving word problems develops analytical thinking skills. So, problem solving by adult learners. So I have good amount of examples how adults learn solve word problems. So and seeing those problems as a mathematician, I can see what can help students to really try to understand the problem and to solve it by through understanding, not following steps. Unfortunately, currently math textbooks, even for college, they show steps. So what is happening, there is a problem and there are steps. Do this, do that, do that, do that, without any explanation. And then what students do when they see a word problem or any problem, they find in the textbook something that matches, in their opinion, which is not always correct, and they follow the steps. If the problem that is similar to the problem in the book, but if I rephrase the problem, they make a mistake because they match with a different one, and then they follow the wrong steps to solve it. So this is one of the examples that I got from my tests from my students. The problem is if you can drive your car 58 miles using 2.5 gallons of gas, how many gallons of gas do you need to drive 1 mile? The student's answer was 145 gallons. It had to be obvious that 145 gallons of gas is too much for driving just 1 mile, right? But basically, what is a problem here with the student, that the students really don't understand what is division and what is multiplication, how they are related. I have even noticed that many students don't know that multiplication is multiple addition, right? 2 times 5, which means 5 twos added, right? And division is the opposite operation of multiplication. Like 2 times x equals 10, this means x, to find x, we need to divide because there was multiplication there. So when I got this answer, I said, throw away that car. It's not good, right? For 1 mile, 145 miles, it's gallons is too much. So my version will be for this problem. So if you can drive your car 58 miles using 2.5 gallons of gas, how many gallons of gas do you need to drive 1 mile? And then I would check your answer before you submit it by performing the following calculations. The gas you need to drive 1 mile should be, choose one, greater than the gas you need to drive 58 miles and less than the gas you need to drive 58 miles. Now, of course, now I'm provoking the student to, I'm making the student to think about it, right? If 2.15 miles is 1 mile, another mile, and half a mile. So basically, it should be less for 1 mile. We'll need less gas, right? So this will make the student first of all to stop and check the answer he had for this student, for this particular student, that 145 gallons is the wrong answer because it's more than gas that he needs for 58 miles, correct? And so after that, so he'll check, hopefully, I think, he will check the second one, less than the gas you need to drive 58 miles. And then the next task that the student has to do is, if you provide your answer, 45 gallons of gas to drive 1 mile, then you need how much gallons of gas to drive 58 miles, right? So for 1 mile is 145 gallons, for 2.5 will be a lot more gas than what is provided in the problem. So comparing these two numbers will make the student to sit back and say, I did something wrong. And most probably they say, okay, I multiplied. No, maybe I have to divide. So that's one example. And another example is, this is a more complex problem. A machine costs $24,900 and has a salvage value of $1,000. Salvage value means after some time, each machine comes with how many units can be used to be good, and after using that many times or hours or miles, whatever is the case, how much the cost of that machine will be. So that's salvage value. If the estimated useful life is 50,000 hours, the unit depreciation would be what? And the student gave the answer $6,000. The correct answer is 0.478. Again, there's multiplication division kind of issue, right? As I said, the same issue that the problem, they often don't understand what is multiplication, what is division. So this problem can be solved by performing two operations. The student failed to estimate that if the machine depreciates by $6,000 per hour, then after 4 hours, the cost of machine will be less than the salvage value. Right? That is, the machine's useful life is less than 4 hours. Well, it is given that the estimated useful life is 50,000 hours. It's huge difference, right? So, and this is my version of the problem. Again, the same text. A machine costs $24,900 and has a salvage value of $1,000. If the estimated useful life is 50,000 hours, the unit depreciation would be. And then my addition to the problem is check your answer before you submit it by performing the following calculations. If the machine depreciates by $6,000, right? If we use this wrong answer per hour, then depreciation amount of 50,000 hours should be, check one, greater than the cost of the machine, less than the cost of the machine. Of course, it should be less than, right? And after checking that and comparing their answer, they will understand that something happened, something is wrong. So if the depreciation amount is 24,900, subtracted 1,000 is 23,900, and the machine depreciated by, we have to provide the 6,000 wrong answer, right? An hour, then the useful life of the machine will be in hours, and compare with the given number. So the student will get 4 there, and will understand that the solution is wrong. But that's all my presentation, and do you have any questions? Oops, sorry, there's a computer. Today is not my day, it's like, anyway. Students learn about addition and subtraction, multiplication, division without understanding. That's my conclusion. They do not learn how these arithmetic operations are related and how to use them. I talked about that before, and I have seen that very simple thing very often, pretty often, when I explain like what's multiplication, as I said, they're like as if they discovered something new, and I was really like, they're adults, and how can they don't know that addition is the multiplication, multiple, right, from the word. In my teaching, I often, when I use a term, I say, what this term means in English? How do you explain, right? Multiplication, multiply, multiple. Yeah, therefore multiplication is multiple addition, or any term, because it's English, right? It's their language. They know the language. They have to kind of compare the word, the term, the new term, with the meaning of the word, and this way they will it will make more sense for them to understand through using language. Without a basic knowledge of mathematics, learning more complex topics becomes challenging, and understanding becomes almost impossible. The use of common sense will help students to avoid providing meaningless answers. Very often, when I try to when I teach my students, they very often they ask, Dr. Marikyan, what I have to memorize here? I'm like, no, my purpose is not to memorize. And I always tell them, when I was a kid, I didn't have excellent memory. And as you can see, I have PhD in mathematics, right? So there's something wrong. Math is not about memorization. Math is about thinking. And you can think also. Although I have heard like a couple of times and saying, oh, Dr. Marikyan, don't make me to think. I'm like, why? So in my teaching, I always try students to think, to understand every step. Why are you multiplying? Why are you dividing? Why are you using this number, not the other number? And if the students understand, then they don't have to memorize. And I also tell them about my story that with using, I remember when I was studying trigonometry in school, there were a lot of formulas and I couldn't memorize them. So